of a number. The parts of a radical are as follows. Okay, does anybody remember this from grade 10? What's the little number called, the little n? Index? What about x when it's inside? Huh? Radicand. And then the whole thing together is called the radical. Okay, so to help you with simplifying radicals faster, you should know your perfect squares and perfect cubes. So what's the perfect cube or perfect square? 1, what would this be? 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169. Can anybody go further?
Yeah.
There you go. Holy smokes, look at that guy. Okay, perfect cubes. Well, 1, 8, 27. I thought I heard it. 64. 64. 125. 216. Some of these numbers should ring a bell because, no? Okay, perfect fourth. You don't use perfect fourth too often, but let's just do it for fun. 1, 16. What's 3 to the power 4? 81. It's escalating very quickly. 256. 625. Okay, perfect fifth. 1. 32. 3 to the power 5. 300. Okay, so we're going to, without a calculator, calculate the following. So what is the fourth root of 6? No, not...
That sums up my math experience right there. Why?
Why? Yeah. Okay, what's the fourth root of 16? It's 2. And the reason I put y is because 2 times 2 times 2 times 2 equals 16. Does everybody see what the fourth root means? What number times itself 4 times gives me 16? Okay, what's the cube root of 216? What's the fourth root of 256? 4. Ooh, here's a hard one. What's the fifth root of negative 32? Negative 2. Okay, so here's some things. You always think you can't square root a negative number, but you can actually cube root a negative number. Why? Because negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Is that 5? 1, 2, 3, 4, 5. If the index is odd, we're coming up to that in a second here. How about this one? Yeah, it's x, but we'll learn later it's actually the absolute value of x. Does anybody remember how to do these? You have to remember fractional exponents from grade 10. So if it's a fourth root, what exponent is it? What fraction is it? So for instance, x squared, let's try this again. If I want to know what the square root of x is, this would be x to the power, about a half. The cube root of x would be x to the power 1/3. Do you remember this again? This is grade 10. The fourth root of x would be x to the power 1/4 and et cetera, right? So this would be m to the power 8 to the power 1/4. So what would that equal? Do you remember your exponent laws? When you have a power to another power, what do? Multiply. So what do you get? M squared. Can anybody tell me what you get for g? You're multiplying 8 times 1/4. K to the power 4. Very good. Why did I get that? Because this is k to the power 20 to the power 1/5. 1/5 of 20 is 4. Yes? Okay, moving on. A radical is in simplest form if the radicand does not contain a fraction or any factor that can be removed. It's in simplest form when the denominator does not contain a radical. That's a no-no. Root 2, root 3, root 5, root 7, those are in simplest form. However, root 12 is not, because it contains a perfect square factor. What's that perfect square factor? 4. So I think in grade 10 they got you to rewrite this as that perfect square. So root 4 times root 3, because 4 times 3 is 12, yes. And then we simplify root 4 to be 2, and then we keep the radical attached. Remember doing that? Okay, so depending on factors of the radical, look for a perfect square or a perfect cube or a perfect fourth, etc., hidden in the factors of the radicand. Okay, so what do I want there? I want square root the perfect square. I was going to say rewrite. Okay, so square root the perfect square or square cube root or whatever it has to be by placing its root in front of the radical sign. And then we're going to multiply any constants. I don't think you did this in grade 10, multiply the constants, but we're going to learn pretty quick. And then leave any numbers without the roots inside the radicand. Okay, so is there a perfect square in root 50? Yes, what is it? So you know that chart that we just did on the previous page? You should be looking here to see what goes into 50. And I always said if you start at where 50 would be, go down from there to see what would be the highest. So 25 would be the highest, yes? Okay, so we would rewrite 50 as the square root of 25 times the square root of 2. And then this simplifies to be 5 root 2. Okay, so do you want to try the rest? Okay, try that. Okay, so 80 is root 16 times root 5, so it is 4 root 5. Is that what you got? Yeah. And root 9 times root 7, so 3 root 7. Yeah. Maybe I should circle my answers here. And then this one is 5, and I'm going to put a bracket just so you just can see what I'm doing here. This is 9 times 2. You see that 9 comes out, and then it's 5 times 3 times root 2. So what do you get when you multiply that? 15 root 2 as my final answer. You have to remember to multiply the two constants at the end. That's what I said right here. This is the new part I don't think you saw in grade 10. You did do that? The 5 times 3? Okay. Okay, so this would be 5 times the cube root of 8 times the cube root of 3. Some of you guys are so good at this, you don't even have to show all your work, right? So this would be 10 cube root 3. Is that what you got? And the cube root of 64 is -4. There's a cube root that goes into -54, and that would be -27 times, what, 2? Make sure you put the index there. It's not a square root. So then you get as your final answer -3 cube root 2. Pull out the negative. Don't leave the negative inside the radical, because that's not simplified. Because technically you can take out a -1 out of a cube root. So if you haven't learned at this point, Oh. Okay, so simplify this. So how would you do this with variables? You need to write it as perfect square. What would the perfect square be that goes into 7? Four is 1, but there's even higher. The square root of x to the power 6? Yes? Can you not square root x to the power 6? Yes? So that would be x to the power 3 root x. Yes? Okay, so how could I do this easily then? What am I in fact doing when I'm square rooting? Square root is the same thing as which fractional exponent? 1/2. So if I take half of 7, I get 3.5. So I know that it has to be the 3, and then the rest will go inside. So you could also do this as like this. You could write it as a fractional one, but I don't think that helps you, right? You can't write it as 3.5, but this is 3.5 if you look at this kind of the same way. Okay, does 3 go into 6? Yes, and how many can I take out then? So this would be a squared, and 3 goes into 10. No, but it goes into something close to 10. 9. So if I take out a b to the power 9, what would come out? B to the power 3, and I'd have 1 b left, right? Okay, so I'm going to show my work because I'm sure I lost some people there. So does everybody see that a to the power 6 that goes into it? So I would write this as b to the power 9 times b to the power 1. Does everybody see that is much nicer? And then because this is 1/3, 1/3 of 6 is 2, 1/3 of 9 is 3, and then I have the leftover cube root there. Okay? So now this is square root. So you want to square root 36, that works. Can you square root c to the power 4? Yes. Can you square root d to the power 2? What do you get? 6c squared d. Yes? Okay, this is a square root. So if you're having trouble with this, rewrite it as perfect squares first. So what's the perfect square that goes into 24? 4 and 6. Okay. Does everybody see what I did there? Okay. E to the power 3. What would be the perfect square? E squared, and then you'd have an e here. Does everybody see that's still e to the power 3? And then the f to the power 5, what's the perfect square? F to the power 4, and then I have a leftover f here. So now I'm going to actually square root this first part. And what do I get? 2ef squared square root 6ef. That would be my final answer. Yes? Okay, you want to try the rest then? Sure. Okay, so the thing is, if you're square rooting, the exponent must be divisible by 2. If you're cube rooting, it should be divisible by 3. Okay, so with the numbers, just do it like we did before. Rewrite it as perfect squares and not perfect squares. So what's the highest perfect square that goes into 20? 4. So it's 4 times 5. Does everybody see that? 4 times 5 is 20?
Yeah.
Now, g to the power 8, 8 is divisible by 2, so that is a perfect square, so leave it there. H to the power 17 is not perfect, so what's the highest perfect? 16. So h to the power 16, then you have the 1h left over here. So now I'm going to actually square root this part. So what do I get? 2g to the power 4, h to the power 8, and then square root 5h. So that's my final answer. Okay. Perfect cube. So here's my perfect cube, and here's my non-perfect cube. So is negative 125 a perfect cube? Yes, so let's leave it in the perfect cube one. Now, what's the highest perfect cube that goes into j to the power 5? Yeah, j to the power 3. And so what do you have left over to put over here? J to the power 2, because 3 plus 2 makes 5, right? When you're multiplying the same base, you add the exponent. Okay, what's the highest power that goes into k to the power 4? K to the power 3. And you're left over with 1k. So then we're going to cube root this first part. So we get negative 5jk cube root j squared k as my final answer. Any questions on that one? Okay, so now we got a little bit of a mess of stuff here. What's the perfect cube? I'm just going to write 2x here because we can't do anything with that at this point. What's the perfect cube that goes into 128? 64. It has to divide, right? 64 times what? 2. And then what's the highest perfect cube that goes into x to the power 4? X to the power 3, and then we have a leftover x over here, yes? Okay, so if we cube root this right here, what do we get? 4x. So now we need to combine those two together. What do we get? 8x squared cube root 2x as my final answer. Okay, so it's only possible to find square roots of positive numbers. Therefore, when doing a root, such as the square root of a, the radical is only defined when a is greater than or equal to 0. When you have a cube root of a, you can have anything. So that's where somebody must have saw somewhere, if it's an odd root index, there will be no restrictions, right? If there's an even root index, there will be a restriction if any of the variables have an odd radicand, odd exponent, I would say, inside it. Okay. I'll show you what I mean in a second here. But, okay, so if we have an odd inside, and you square root it, do we have a restriction there? So for instance, okay, what would we normally do here? We would take the highest power, right? So we get x to the power 6 times x. Is everybody good with that? So what do we get here? We get x to the power 3 root x. Does everybody see that's our final answer? But here's the thing. Having this leftover x in here, you can't have a negative number for x, right? Because you can't square root that. So you'd have to put the extra restriction, comma, x has to be greater than or equal to 0. Okay? Actually, it's just asking for the restriction. So the restriction is x has to be greater than or equal to 0. Okay, how about this one? Is there a restriction? No. And if you want, you can think about this for a second. If you put whatever you want in here, like you put positives or negatives, if you put it to the power 6, it'll get positive, and then you can square root it. So there is no restrictions. Does everybody see that? How about this one? There's restrictions. The inside has to be positive. Now, how am I going to make the inside positive if the -3 is already there? The b would have to be a negative as well. So does everybody see it would have to be less than or equal to 0? I will repeat why that's the case. In order to square root this, you have to have a positive inside. The whole thing has to be inside. If the -3 is already there, you have to make that inside positive. The only way that you can make it positive is by having b to the power 5 negative, because a negative times a negative is a positive. Do you see right here, this is an odd index? We don't even have to look inside. There's no restrictions. This is an even, so we cannot fourth root negatives, right? Everybody agree? It's just like a square root. You can't find a number times itself 4 times and have the answer to be negative. Does that make sense to you? Okay, so that means in order for that to happen, what does b have to be? Greater than or equal to 0. Okay. So, what do I want there? An entire radical. This is what I think Holly was trying to do here. She was trying to make 5 into root 25. And what happens with that, if you make it into entire and then you multiply the inside, it gets really big numbers. So it's easier to take things out and multiply smaller numbers that are constants. So does everybody see? 5 would become root 25. 5 would become cube root 125. That's how you bring it back in. 6 would become root of 36. 2 would become cube root 8. So who could tell me what 3 root 2 would become if it's an entire square root? I heard it. 18. Very good. Does everybody see why it would be 18? Because 3 would go into the square root as a 9. And 9 times 2 is 18. Okay, see if you can get this one. What'd you say, Zach? Yes, it would be 54. Because this would come into it as a 27, yes, and 27 times 2. Okay, I'll give you a second to figure out example 5 then. So this becomes a 4, so we get root 52. This becomes a 9, so we get root 54. Okay, continuing, 4 squared would become a 16. 16 times 5 would be root 80. You shouldn't have 80, it should be root 80. 5 would get squared. 25 times 2 is root 50. Did everybody get that? So now we're going to arrange it from greatest to least. The only way you can do radicals from greatest to least if you actually look at it as entire radicals. You did this in grade 10. So what is the greatest? The root 80. So 4 root 5. Then what? And the 54. So then 3 root 6. Then after 54 would be 52. So 2 root 13. And then last would be the root 50, which would be 5 root 2. Okay.